this is the fourth lesson from the computer hardware unit, and we'll have a look at the CPU in a bit more detail. We'll understand how it works and how we can measure performance of the CPU. Okay, so where is the brain of the computer and what does it do? Well, let's have a look. So the CPU stands for Central Processing Unit. It's known as the processor. It's known as the brain of the computer. It's placed on the motherboard, and a computer system could not function without one. Just like a human being cannot function without a brain, a computer cannot function without a CPU. Now the CPU will live on the motherboard, has its own little port. CPUs get exceptionally hot very, very quickly. And because of that, heat needs to be drawn away from the CPU. So on top of a CPU, we'll often have a heatsink, which is a metal block with lots and lots of grooves, with lots of large surface area, so that heat can be drawn away from the CPU. And often on top of a heatsink, you will also have a fan to ensure that the heat gets taken away at speed. Okay, so every computer needs one because it is, or acts like, the brain of the computer. It is responsible for performing calculations and doing all the decision making. And it's also responsible for coordinating all the hardware. So it coordinates things like the monitor, the keyboard, and the mouse. It takes inputs from input devices, it processes them and produces outputs which are sent to the output devices. Again, without a brain, the computer can't function. The brain of the computer is the CPU. It needs one in order to function. Okay, so how does it work? Well, the CPU will carry out the fetch, decode, execute cycle. Now, what the fetch, decode, execute cycle entails is this. First of all, the CPU will fetch an instruction from the RAM. Remember, the RAM is the short-term storage, memory storage area, where all programs that are loaded, that are running at that time, are placed onto the RAM because it's really quick at talking to the CPU. So the CPU will fetch an instruction from the RAM. Once it's fetched that instruction, it needs to make sense of it. Now, the decode stage is where it makes sense of the instruction. So it decodes the instruction. It understands what the instruction is going to be for. And once it's understood the instruction, the CPU is going to execute the instruction. So it's going to perform the calculations, or it might move data from one place to another. But it's actually going to carry out that instruction. So CPUs carry out the fetch, decode, execute cycle, where it fetches an instruction, it decodes it, makes sense of it, and it executes it. And then it will do the cycle again, and again, and again, and it will do it exceptionally fast. So how fast does the CPU actually work? Now, all CPUs have a clock speed. So it's the amount of instructions that the CPU can process in 1 second. So the time frame is 1 second. And it's measured in hertz, so that's cycles per second. Now, modern day CPUs currently run at about 3 gigahertz. Now, what is a gigahertz? Well, that is 3 billion of these cycles every second. So it potentially can fetch 3 billion instructions, decode 3 billion instructions, and execute 3 billion instructions every single second, which is phenomenal. So CPUs have a clock speed. It's the number of instructions processed per second, and it's measured in hertz. The faster the speed, the more instructions can be processed. Okay, so we've understood that the CPU stands for Central Processing Unit, that the CPU carries out the fetch, decode, execute cycle, fetches an instruction from the RAM, makes sense of it, and executes it, and that the CPU is measured, or the clock speed determines how fast the CPU can work. It's measured in hertz. The faster the CPU, the better the performance. And remember, instructions processed per second is the cycles per second.